Good evening, everyone. Slides are visible.
Yes, ma'am. Good evening, ma'am.
Good evening. So let's start today's session. Today is your problem solving session 13th and it's your last session. So firstly we will solve some questions, then we may take it out. So the first question is that which of the following techniques can be used to distinguish between two isomers? Like these are the two isomers.
All of this.
Like these two isomers are given and like can you distinguish from mass 13C and proton? So the correct answer will be
All three.
all three because mass 13C and proton all will give different signals. Like if you will look for this proton in the proton NMR, so like so by looking on the structure you can simply see the splitting pattern will also be different from the proton 13C. Like if you will take a look at here for these two protons and the next carbon doesn't have any protons, so these two will appear as a singlet. Similarly, you can calculate the splitting pattern for all, so there will be difference in the proton signals for both the isomers. Therefore, you can easily distinguish from proton as well from 13C. And if you record mass also, then from mass, the M by Z will be different for both. So you can easily distinguish these two isomers from mass 13C and proton. Similarly, now the next question is again from the NMR. Like what is the reference compound that is used in the NMR spectroscopy? Silane, tetramethylsilane, dimethylsilane or trimethylsilane?
Tetramethyl.
Tetra-
Correct. It will be tetramethylsilane. And the reason why we use tetramethylsilane we already discussed in the session. So this is the structure of the tetramethylsilane. There are all CH3 groups. So the next question is mass spectrometer separates ions on the basis of mass, charge, molecular weight or mass to charge ratio.
Mass to charge ratio.
Correct. It's mass to charge. This is M by Z. Now next question. Which of the following compounds gives three signals in NMR? CH3COH, CH3CH2NH2, CH3OCH3, CH3CH2Cl.
Second option.
Second option. Like if we will look on Acetic acid first, CH3COOH. So how many signals will be observed here?
2.
Correct. One for the OH one and another for the methyl. Now if you look upon the CH3CH2NH2, here how many signals we will observe?
3.
Correct. One for this, second for methyl, and third for uh, this CH2, CH3, CH2, NH2. So these all are different, having different chemical environment. So there will be three signals. So the right answer will be CH3, CH2, NH2. Similarly, if we look upon this ether, how many signals we will observe?
1.
One, because both the methyls are having equivalent environment. And in CH3, CH2, Cl, how many signals we will observe?
2.
Correct. So the answer will be CH3, CH2, NH2. Now next question. How many peaks will be observed in the proton NMR spectra of CH3 whole twice? Like I can draw the structure. So now how many peaks will be observed for this structure?
3.
3. Like one belongs to this methyl, other belongs to this H, and these two methyls are having the same chemical environment. So total there will be 3 peaks that we will observe. Now next question. In proton NMR of given below compound should have 4. Uh, just a second. For example. So the proton NMR of a given below compound shows 4 signals. Predict the splitting pattern, singlet, doublet, doublet of doublets for each signal. So basically in the structure there are 4 types of proton that are visible. So what will be the splitting pattern for the first one, like this hydrogen? For this one, the first one.
Doublet.
Uh, yeah, it will be doublet. Why? Because the next adjacent carbon has only one hydrogen, so it will be n plus 1. That is 1 plus 1, that means doublet. So for here you will observe a doublet. Now for the second carbon, this one. So what will
Doublet.
the doublet, correct? It will also be doublet because the adjacent is oxygen and the second adjacent is the carbon that has only one hydrogen. So 1 plus 1 is 2. That means doublet. For the third one, the methyl one,
Single.
it will be singlet because it is attached with oxygen and there is no hydrogen. It's singlet. And the fourth one, now fourth one is attached to two carbons. One is having singlet and other is having, like one is having one hydrogen and other is having two hydrogens. So what will be the pattern?
Doublet and triplet.
Correct. It will be doublet of triplet. So the correct option will be doublet, doublet, singlet, and doublet of triplet. Now, next question. Correct order of chemical shift of proton is. So what will be the correct order of the chemical shift of proton? Like who will have a highest chemical shift
Option
value?
Second option.
Why? Why it is second
Fluorine is
option?
more electronegative.
Correct. Fluorine is more electronegative. So means that it means if a compound is more electronegative, that means it has a more electron withdrawing character. That is, it will be more de-shielded. So the chemical shift value of the fluorine will be higher. Then it will be chlorine, then it will be bromine, and then it will be iodine. So the correct answer will be this one, because fluorine is the most electronegative element. Now next, what will the delta chemical shift value of the aldehydic proton in the proton NMR? So what will the
9 to 10.
9 to 10, correct. Next question. The mass spectrum of acetone shows a major peaks at M by Z 58, 43 and 15. What can we deduce from this data? Like first, let me draw the acetone structure. This one.
Ma'am, for previous question, should we remember that value, ma'am, 9 to 10? Or
Yes,
any
because
method
like
is
no,
skip?
actually, like in the previous session we discussed about some of the values of, like, you have to remember for sp3, sp2, sp hybridized one, aldehydic. Some of the values
Okay, ma'am.
you should remember. Some of the basics value in the animal you should remember. Others you can simply look upon the structure, like if there is some electronegative group attached, then means it will be furthermore de-shielded, then the chemical shield will be higher. If similarly there is aromatic protons comparative to aliphatic, so aromatic will nearly come in the range of 6 7 something, if 5 6 7 something. If it is aliphatic protons, then it may come in the range of 2 3 1 respectively, depending on the structure. So in the previous
Okay,
session
ma'am.
we made one table na, in which we told about like what's the value for the sp3 hybridized carbon, sp2, sp. That table you should remember.
Then what
Okay, ma'am.
should be the value of alkyne? Alkyne, SPSP.
What is the value of?
For the alkyne, SPSP.
See, we will I will write it down.
Because ma'am, there ma'am, SP character is more, means S character is more, means more
Hmm.
electronegativity, means more de-shielded. So it should go away, means chemical shift should be higher, value should be higher. But I think there is exception, means its value is coming towards 2 to 3, I think so.
Just
Okay, ma'am.
remember for this thing, like I drew. See, there is sp3, sp2 and sp. Since you know that in sp there is 50% s and 50% p character, no? In sp2 how much is the s character?
25.
It's 3, 100 by 3, 33. It's 33%. And so more s character is in sp. And you know, if more is the s character, then it means more, it will more electronegative, it will be more electronegative, because if you will see about the nucleus, the s orbital is more near to the nucleus, so the force of attraction will be more towards the s. Similarly it comes p, then comes d orbital. As the s orbital is near the nucleus, so the force of attraction will be more, so s is more electronegative than p and d. So in sp if you will look, it has the highest s character comparative to the alky, comparative to the sp3 and sp2. sp is the alkyne one, the triple one. So if you will look upon the values in the NMR, 2 to 3 is the value of the sp hybridized carbon, 2 to 3. And if you will look for the sp3, that is alkanes, it will comes about to be 0.1 to 2, 0.5 to 2. for the alkanes. But the value may be changed, like it may be shifted depending on the structure. Like suppose if your carbon is sp3 hybridized, but there is some electronegative group attached to it, then the value may further go towards de-shielded direction. Then the value may be go beyond 2. It will be approx 2 to 5, in the region of 2 to 5. So it depends. So your point is correct, like sp has more s characters, so the chemical shift value should be higher. So you can easily see if you are comparing sp3 in sp3 the chemical shift value is 0.5 to 2 ppm, but in sp hybridized it's 2 to 3. Now you got it.
But aldehyde has sp2 hybridization right now.
See what's aldehyde. Aldehyde can be, you can take any, because in aldehyde there is an electronegative element oxygen attached to it.
Okay, ma'am. So
So you,
delta value increases.
yes, so that you have to take a look on that, because in aldehyde generally the value ranges from 8.5 or 9 to 10. Like you can just remember, I will tell you one table. Just remember that, that will be helpful to you. Like 0.5 to, so 10 to 12 is the range of acid. 8.5 to 10 is the range of aldehyde. 5 to 8.5 is the range of sp2 hybridized carbon. 2 to 3 is the range of sp hybridized. 0.5 to 2 is the range of sp3 hybridized carbon. And if suppose your sp3 hybridized is attached to some electronegative element, say X, like it can be chlorine, bromine, so the range can be 2 to 5. So this table you can easily remember. So 0.5 to 2 it will be sp3, 2 to 3 sp, 2 to 5 will be sp3 hybridized attached to some halogens. Then 5 to 8.5 it is sp2, 8.5 to 10 it's aldehyde, 10 to 12 is acid. But the value may vary depending on the structure or the groups that is attached to that element. Now it is clear?
Yes, ma'am.
Okay. So we were discussing about the mass spectrum of the acetone. So basically this is structure of your acetone, CH3, CO, CH3. So what will the ambazite value of acetone? They are telling that it will show 3 peaks at 58, 43, 58. What can be deduced from these data? The parent ion is observed and fragmentation involves 2 CC bonds cleavage. Parent ion is not observed. Parent ion is observed and fragmentation involves loss of CO. Parent ion is observed and fragmentation involves cleavage of CCO. So basically what happens in
Option
acetone,
one.
option,
Option one first.
no, it will be option
It
4.
should,
There will be no, the option will be fourth, because there will be cleavage of the CC bond, like the next carbon attached to carbonyl is your alpha carbon, so there will be alpha cleavage. So when there will be alpha cleavage, then there will be formation of this kind of acylium ion, and a methyl radical can be formed, like from here. And you know that in mass the radicals are not detected, they can generally go to vacuum. So we can only see the mass of this asylum ion, and if we calculate the MZ value, so it will be 43, and Z means charge is 1, so MZ will be 43. So this 43 corresponds, this MZ 43 corresponds to that of asylum ion. Now one more like possibility of fragmentation is there is formation of methyl cation and acyl radical. This is your acyl radical. And now if you calculate the mass of methyl cation, it will be 12 plus 3, that is 15. 15 by 1, that is 15. So M by Z is 15 for the methyl radical. So now you got it, the fragmentation is due to the cleavage of one CC bond. So the correct answer will be parent ion is observed and the fragmentation involves cleavage of CC bond. Is it clear?
Yes, ma'am.
Now next question. A proton NMR spectrometer operates at 300 MHz. Find the value of magnetic field. And GN
Ma'am,
and
but there is the ma'am, in that previous question, there is no cleavage of that two C
but
single bond.
two CC
There
bonds
is
will
no.
not be broken, no? Like only alpha cleavage will happen at one carbon because other there will be acylium cation will form. There is like they are asking about cleavage of two CC bonds. Like both the methyl are not cleaved, no? Only one methyl is cleaved. This one. If we cleave both the cations, then this will be formed, no? CO will form.
Okay, ma'am, got it.
And we are not getting M by Z value here, no? We are getting M by Z at 43 and 15. So you have to take a look at the fragmentation pattern also. Because if it will be CO, then the mass M by Z value will be different, no? Now next question. PMR spectrometer operates at 300 megahertz. You have to calculate the field strength and your nuclear magnetic value, and the BN value is given, and the GN and BN value is given. So you know this formula, like we discussed, that frequency is equals to gamma by mu naught. Yeah, this is your Lambda frequency. Gamma was your
The-
gyromagnetic ratio. Yes. And what was your B naught? B naught was your magnetic field strength. Now you have to calculate the value of B naught. So B naught will be frequency by gamma. So gyromagnetic ratio and the frequency you have to calculate. Like frequency, you know, it is equals to 2 mu f. So 2 into 3.14 into f. What is the frequency? It is 300 megahertz. So it will correspond to be 1.884 into 10 raised to 9 radian per second. This will be your Raman frequency. Sorry. Now we can calculate the gyromagnetic ratio. For gyromagnetic ratio, value of Gn and Bn is given. Just a second. So the gyromagnetic ratio is equals to Gn into Bn divided by h cut, and h cut, h cut is h by 2 pi, and h value, it's 6.626 into 10 to the minus 34 divided by 2 pi. Pi, that. So just substitute the value. Gn is 5.585 multiply Bn is 5.05 into 10 to the minus 27 divided by h cut. H cut, it's h by 2 pi. So h is 6.626 in 10 to the minus 34, 2 pi, 2 into 3.14. So after solving it, the h cut will be 1.056 into 10 to the minus 34. So after solving, the gyromagnetic ratio comes out to be 2.67 into 10 raised to the power 8. So now you know the value of frequency and the gyromagnetic ratio. So to calculate the magnetic field strength, just divide these two values. So the answer will be near about 7.04 something. So it will be approx 7.05 Tesla. So the option first will be correct. Is it clear? So you have to
Yes,
remember
ma'am.
these three formulas. Now next question. How many signals do you expect to see in the proton NMR of 2 bromopropane and 1 bromopropane? So let's draw these structures. So this is structure of 2 bromopropane. Similarly, this is structure of 1 bromopropane. So tell me how many signals will you observe in these two cases?
2 and 3, ma'am.
2 and 3. Which will be 2?
First one is 2, ma'am.
Last one is 2.
First one, ma'am.
This one.
Yes, ma'am.
Correct. Why? Because chemical environment of these two are same. So one signal for this and the second signal for this one. Similarly, one signal for this, second signal for this, and third signal for this. Because here in CH2, Br is attached directly. So the chemical environment is different. In here in this 2 CH2, where chemical environment is different, and this methyl also has a different chemical environment. So three signals for the 1 bromopropane and 2 signals for 2 bromopropane. So the answer will be 2 and 3. Now next question, which cannot be used as an analyzer in mass spectrometer? Ion trap, TOF, ESI, quadruple. So what will be the answer? Which cannot be used as an analyzer?
Yes, sir. Yes.
ESI, correct. Why? Because ESI is a ionization technique, and all these ion trap, TOF, quadruple are the analyzers. The answer will be ESI. Now next question, what is the wavelength of an electron moving at 5.31 into 10 raised to 6 meter per second? Mass is given and h is given. So you have to calculate the wavelength of an electron. Mass is given and this mass you have to remember also. It may happen that it is not given in the question. Mass, h value, this you should remember. So just solve and tell me the value of wavelength. Wavelength you have to calculate. So just tell me the formula. Which formula you will use to calculate the wavelength?
Lambda is equal to h upon mc.
Correct. Lambda equal to h upon m. Now everything is given. You just have to directly apply in the equation. So the wavelength comes out to be Armstrong. So it will be 1.37 Armstrong. So now we will discuss some of the concepts that we have discussed in a previous class. So we discussed like there are various spectral series in the hydrogen. The first one is the Lyman series, then comes your Balmer, then comes your Paschen, then comes your Bracket, and then comes the Fund series. And remember, in Lyman series the transition is from the first orbit. It means the n1 will be 1 and n2 will be 2, 3 and so on. Similarly, Balmer series, in this the transition is from the second orbit. That means n1 will be 2 here and n2 will be 3, 4, so on. Similarly, you can calculate for the Paschen, Bracket and the Fund series. Here n1 will be 3, here n1 will be 4, here n1 will be 5. Similarly, n2 will be 4, 5, so on. Here n2 will be 5, 6, here n2 will be 6, 7. And remember that Lyman series is in UV, like Palmer series in the visible, Paschen in the IR. These you all just remember that. Now there is ground state term symbol. So what will be the ground state term symbol for the D2 configuration? For D2, you know the term symbols is represented by
3f1.
3f. For D2 it's 3f. And what's the J value?
2.
1.
See, J value we discuss. There can be three possibilities. It can be either L plus S, it can be L minus S, or J can directly equal to S. When it is more than half filled, then it's L plus S. When it is less than half filled, then L minus S. And when it's exactly half filled, then J equals to S. So now if you will take a look for D2, so what's the S value? Half plus half, it's 1. And what will the L value? 2 into 1 plus 1 into 1. That means 3. And S, P, D, F. 0, 1, 2, 3. So the L value is 3. That means F. And 2S plus 1. S is 1. So 2 plus 1 is 3. 3F and J. Now it is less than half filled. So it will be L minus S. That means 3 minus 1 is 2. So it will be 3F2. Is it clear? Is it clear? Do you have any doubts or should I explain it again?
Ma'am, what is less than half filled, ma'am, in this case?
See, basically, you know that s orbitals p in x you can occupy maximum 2 electrons. P you can occupy maximum 6 electrons.
6,
For D it can be maximum 10.
10.
So but in the question they were asking about D2, there was only 2 electrons. D2 there are only 2, so maximum it can accumulate 10, but there are only 2, so it's less than half filled now, because what will be the exact half filled of 10? It will be 5, and here there are only 2, so it is less than half filled. That's why we are using J equals to L minus S. Just take a look at the orbital, like they are asking for the D2. In D it can accumulate maximum 10 electron, but it's only 2, so it's exactly less than half filled. That's why we are using the formula J equals to L minus S. Is it clear?
Yes, ma'am.
Now just tell me for the D8 system. D8. D8 means there are how many unpaired electrons? Like how many total electrons? 8.
A4. Unpaired 2.
Unpaired will be 2. So first you have to occupy singly electrons, then you have to pair up. So basically there will be 2 unpaired electrons. Now if you will calculate the S value. So S value will be, how much will be S value?
1.
1.
1.
And 2S plus 1, that means 3. And what will the value of L? L.
3.
It will be 3. 3 corresponds to F.
F.
And
3F4.
and J value it will be, now you may see there are 8 electrons. So 8 is exactly more than half filled. So you will use
L plus S.
correct. So it will be 3 plus 1, that is 4. So the answer will be 3F4. Now it is clear?
Yes, ma'am.
Okay. Like one more we discussed na ground test term symbol in case of diatomic molecules. So we will solve one example for that also. So in case of diatomic one, we were having sigma, pi, del and phi. Sigma is corresponds to where L is 0. If L is 1 then it's pi, L is 2 then delta and L is 3 is phi. So for here we use this formula 2s plus 1 L. It can be zerate or ungirate. So tell me for the helium 2 positive. So what will be the term symbol? So what will be the ground state term symbol for helium? See, firstly we have to write the electronic configuration. It's sigma 1s2, sigma star 1s1 because there is also one electron. It's helium 2 positive now. So the electronic configuration is sigma 1s2, sigma star 1s1. Now the last
2
electron is in
sigma star mu.
2 sigma.
Star mu.
It's not mu, it's u. G-red and ung-red na, so we use u.
Say U.
And
Say.
star is not there, it's plus. So how it comes? It's correct. So for the 1s1, the last electron is in anti-bonding orbital. There is one electron here only. So what will be the s value? S value will be half. So 2s plus 1, that is 2 into
Oh,
half plus 1, that is 2. Now the electron is residing in the s orbital, and we know for the s orbital the L value is 0 and L value 0 means sigma. So that means 2 sigma. And why we have used the plus sign? Because we know that we have, when we study the rules, that minus subscript we used when electrons are filled in the pi orbital, but here there are no pi orbitals, so here is plus sign. And what's zeroed and unzeroed? As the last electron is in anti-bonding orbital sigma star, that's why it's unzeroed. Therefore it is 2 sigma u positive. Is it clear?
Yes, ma'am.
Now we also discuss like some formulas, like what were the total number, like a simple formula to calculate the number of spectral lines. So it can be n2 minus n1 multiply n2 minus n1 plus 1 divided by 2. So there was one formula in which we can calculate the spectral lines by this formula. One, you should remember that Rydberg's formula, that is 1 by wavelength equals to r 1 upon n1 square minus 1 by n2 square. And Rydberg constant value, you should remember, it's 1.097 into 10 raised to power 7 meter inverse. One more question I think Rohit asked me in the discussion forum.
Ma'am, value is 109678 also.
Yeah, it's approx like 1.097 you can take.
Okay.
Like how can we calculate the I think population of the two states? So the formula is n2 by n1 equals to E minus del E by kt, where this is the population of the two states. If you have to calculate the population two states, thus you should know the value of energy gap and the Boltzmann constant and the temperature. And temperature here we always take in Kelvin. So if in the question it's given in Celsius, so we have to convert in Kelvin. And K is the Boltzmann constant, delta E. And suppose like if in the question they are telling you to calculate the ratio population states of some laser or something, if wavelength is given, so just convert that wavelength to energy, then use this formula. So you can easily calculate the ratio of population of the two states.
Ma'am, when the Kelvin and when the degree Celsius will be used in case
So
of
here
unit of
only,
temperature?
so here always you will use Kelvin. So like in the question they might give you as 300 Kelvin, so you can directly use. But if in the question it's given 25 degrees Celsius, so you have to change into Kelvin by adding 273.
Ma'am, population of two state will be n2 by n1 equal to the value will come that
Yes,
will
like
be the
suppose,
population of state. No?
suppose your value
Means n2 by n1 is the
ratio,
ratio that is
yeah,
called
correct,
as population of two state.
correct.
Okay.
Because this is the two states, no, upper level and the lower level, N1 and N2 are the two states of both the levels. And for the UV, like we discussed this formula, A equal to ECL. Like A is the absorbance, E is the mole extinction coefficient, C is the concentration, and L is the length. Now we will maybe solve one question about the Laguerre polynomial. Like how to calculate the Laguerre polynomial. So we know that Laguerre polynomial is LPQX is equals to dp dxt LQX. LQX now equals to EX dq d raised to power q dxq e minus x xq. And you should remember p is equals to l plus 1, q equals to n plus l. So suppose if your q value is 1, and p value is also 1, so you have to calculate the Laguerre polynomial of L11. So how you will solve it? So just put in this equation LQX1 that if q is 1, it will be EX d1 dx1 e minus x x is to power 1. Now ex will be as it is, and now you have to differentiate e minus x and x. So first differentiate e minus x. So the differentiation of e minus x is minus e minus x. Then x will be kept constant. Then addition sign. Then e minus x will be as it is, and there will be differentiation of x. So ex minus e minus x x plus e minus x, because dx by dx is 1 only. and you know that multiplication of ex into e minus x is 1. So now if you multiply ex into e minus x, then it will be 1 only, so minus x plus 1. So this will be a value of L1x. So your L1x comes out to be minus x plus 1. So now you have to calculate for the LPQX, equals to dp by dx p LQX. Now you know p is also 1, q is also 1. Now this value you have calculated, it's minus x plus 1. So d by dx minus x plus 1. So dx by dx is 1 only. So the answer will be minus 1. So L11 is equals to minus 1. So this is your Lagrange polynomial of L11x. Similarly, you can calculate for L21 or L31, whatsoever is given in the question. Is it clear? Or should I explain by taking one more example?
Clear, ma'am.
Ma'am, can you show the previous slide? Like, this one.
Basically, you have to remember these two formulas and these. Sometimes they will not give directly the value of P and Q now. So they will tell you in terms of maybe N or L. Then you have to convert it into P and Q and then solve it.
P is 2L plus 1, ma'am.
P is 2L plus 1 and Q is N plus L.
Okay.
Because they may ask you sometimes in form of 3P, 3D. So you can calculate. If 3P is there, then N is 3, like that. So can I change the slides now?
Yes, ma'am.
Now then we discussed about IR and Raman also. Just remember that a molecule, how can we say a molecule is IR active? If there is change in some dipole moment, and if there is change in polarizability, then we can say the molecule is Raman active. Then we discuss about the fluorescence also. Like what do you mean by lifetime? That the mean average time that a molecule spent in that particular excited state is called the lifetime of a molecule. And in UV also, when we discuss about UV fluorescence, we discuss about frat efficiency or the lifetime, and we discuss this formula that lifetime equals to quantum mean divided by rate constant of the fluorescence. Then we discuss one formula about the efficiency, that it is equals to R06 plus R06 plus R6. This R0 is your Foster radius and R is the distance between the donor and the receptor. So these are some of the basic formula you should remember. Then in the mass, you should remember that what is the natural abundance. Like if you have to solve for chlorine, then it's 75:25. That means 3:1. Suppose if you're solving for bromine, bromine will be 1:1. Similarly for carbon, hydrogen. Like for 13C, the abundance is 1.1%. For deuterium, it's 0.015%. And in halogens, always remember that there is difference of 2. So one isotopic signal will come at m plus 2, then another will come at m plus 4. But in carbon hydrogen, the isotopic signals are m plus 1, m plus 2, m plus 3, so on. So this you have to remember for the mass spectroscopy whenever you're solving some questions. And for the halogens, remember that like if number of halogens will be equal to the isotopic signals. Suppose you have two halogen, like suppose you're calculating for molecule in which there is 3Cl. So that means your isotopic signals will be total 3. So it will be m plus 2, m plus 4 and m plus 6. And just remember that in generally for the bromine, whatsoever be the number, it will follow the Pascal's triangle. Like if it will be 1 plus 1:1, then it will be 1:2:1, then it will be 1:3:3:1, like that. For bromine, there is Pascal triangle that is followed. Then in the UV, you should remember that log I naught by I is equals to A equals to log I naught by I, A equal to ECl, or if you have to calculate the mole extinction coefficient, it will be A by Cl. And if you have to calculate the rate constant, it will be quantum yield by fluorescence lifetime. So this all you have to remember, like what is quantum yield. It can be emissive rate of the fluorophore divided by emissive rate of fluorophore plus non-emittive rate. So this all you should remember. Are there any doubts further?
What will be the exam pattern, ma'am?
Like it's, I think it's already shared in the mail.
Like it's computer based, but will it be like MCQs or fill in the blanks, or how many questions will be there?
I think it was shared now in the mail. Like they told me like there will be short answer question as well.
No, ma'am. In general, for this course, we didn't receive, ma'am.
No, it was like it can be MCQs, fill in the blanks, and it can be essay type answers.
An essay type answer, how we will write means we have to write in the computer.
When they mentioned it is computer based, ma'am.
Uh, Maybe there will be some option in that. Oh, like they have told you know, like the questions will be on the computer and you have to write your answers on a sheet of paper, and then you have to
No,
submit the
ma'am.
answer sheets.
No, ma'am. It is like
No, ma'am.
marking in
That's
the
just for
computer.
calculation. We should click on the right answers. I think it's like that.
I don't know. Like I received one mail. In that mail, they have mentioned that type of exam will be computer based exam, but maybe you have to check. And they told you like the questions will be on the computer and you will have to write your answers on sheets of paper. I think there are
They
two
have
types of
mentioned that
exams.
online mode is there.
I think there are two
Only
types of
online mode.
only online mode. Then you have to write in
Yes,
the
yes.
computer itself.
Only online mode is there. No hybrid or
Okay. Then you have to write the answer on the computer itself. There will be some option for that also. Because if it is
Ma'am, lecture
online only,
notes have not been uploaded. Ma'am. Do you have any other notes, ma'am?
that you can ask in the forum actually or the instructor directly.
They are not responding, ma'am. If
haven't
you have any
responding yet.
reason,
We write a mail also. They haven't responded yet.
Okay, actually I don't know about that. So do you
do
have
you have
any doubts
any
regarding
notes?
the session? Like as this is your last session.
No, ma'am.
So everything is clear?
Yes,
So
ma'am. Thank you
that's
for
all.
your support, ma'am. We got a more doubts clarified in your doubt sessions, ma'am. It is very helpful to achieve good marks in the final exam, ma'am. Thank you, ma'am. Thank you very much.
Thank you so much.
Hello,
Yes, Rohit, I guess.
ma'am. One.
Rohit, you're not audible actually. Your mic is off. Actually, Rohit, your mic is off.
Hello,
Yeah, it's
hello.
on.
One question is there. I have written in the chat box.
That I have solved. See, basically in that question, it's mass is given and velocity is also given. So you don't have to use
Yes,
that
yes.
momentum question.
Y-
Directly you can solve by multiplying zero point 0.5 into 20. Because what's momentum? It's P equals to mv.
Because momentum is equal to directly mass into velocity,
So you can directly use this formula 0.5 into
and the
20.
delta x is given for confusion also. That's it.
Yeah, because like what's uncertainty?
Because
So
I have solved by according to that delta x into delta p is equal to h upon 4 pi. I am trying to solve that question by that formula,
because
but I
in
am not able to get it.
because in that question also it's P na, so you have to multiply by mv. Yeah, that's what. Yeah,
Yes, yes, because they have asked momentum. They according to that formula, there is no need of mass and velocity. And
correct.
if you solve by a formula you have said, there is a no need of delta x. Like that thing is there. So we have to directly multiply 0.5 into 20. That will be the answer final.
Yeah, it will the answer 1 into 10 raised to the minus 5, I guess. No, it was
No, no, no.
actually I just saw it, like you messaged something, no? 1 into 10 raised to minus
Mm-hmm.
6.
Directly mass multiplied by velocity. 20 into 0.5.
Yeah, you have to directly multiply it.
Yes, yes. Okay, ma'am. 10 will be the answer.
It will be 10 into 10 raised to minus 6, or you can simply say 1 into 10 minus 5, like what
Ma'am,
you said.
how 1 in 10 into, because 20
It's
multiplied
same
by
now, like
0.5.
10 into 10 minus 6 is 1 into 10 minus 5 only, no? It's same.
Okay, ma'am.
Yeah, it's 10 minus 5.
But 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 answer given in the on the portal is 1 into hence I'm got confused
Which
because
portal? Like,
answer one on assignment answer is in assignments answers NPTEL portal there is an assignment answer there answer given is the 1 into 10 raised to power minus 6. Answer is coming 1 into 10
oh,
raised to power minus 5, and only one answer
actually,
is
I
correct.
don't have any rights. Like, actually, the instructor is.
Hence I am
Yeah,
asked that question.
okay. Yeah. So the answer should be 10. It might be there's a mistake. Yeah,
Yes, yes. Okay, ma'am.
okay.
Thank you.
Thank you.
Ma'am,
Yes, Arpita.
ma'am, can you please tell me that L P by Q X P equals to L plus 1, Q equals to X plus L.
That Lagrange
Um,
polynomial one.
yes.
Like, should I repeat it again?
Yes, ma'am.
Okay. Uh, just next slides are visible now.
Yes, ma'am.
See. So basically for the Lagrange polynomial, it's LPQ, that L raised to power P and Q. So you have to remember these two formulas like this one. Maybe I will just point it. Yeah. So these two formula you have to remember. And what's P sometimes in the question directly they can't tell you, like you have to calculate the Lagrange polynomial of L11 or L21. Simply they can ask you like for the 3P, 2D like that in terms of N and N terms. So from that you can calculate the PQ value, like P is 2L plus 1 and and Q is N plus L. So suppose in your question it is asked like what's the Lagrange polynomial for L12 if P is 1 and Q is 2. So for solving this you need the value of LQX. Like it's dp d raised to power p divided by dx raised to power p, and then it's multiplied by lqx. So you need to know the value of lqx. So firstly we will solve the value of lqx. So lqx is ex d by dx raised to power q multiplied by e minus x raised to power q. So simply like if p was 1 and q was 1 also, then we solve it by like lqx. Instead of q we write it 1. So ex d by dx as it is, and q was 1, so d1 by dx 1 into e minus x raised to power q. So q was 1. So we just have substituted the value of q in this equation. So then ex is we have written as it is. So differentiation of e minus and x, as there are two functions. So how you will differentiate it? So you will firstly keep the first function as it is. Like you will maybe you can first differentiate the first term, like here there are two terms e minus x and x. So firstly we'll differentiate e minus x and the second term will be constant. Then plus sign. Then you will keep the second term constant and differentiate the first term. So it will be ex multiplied by minus e minus x into x plus e minus x dx by dx. And you know the multiplication of ex and e minus x is 1. So after solving it, it will be minus x plus 1. So now you know the value of LQX. So you will put this value in the first equation, that LPQX. So when you will put this value in this equation, then you will observe that L11x equal to d by dx, as p is also 1, so it's 1. And LQX simply you can write the value that is minus x plus 1 that you've calculated. So the differentiation of minus x plus 1 is minus 1. So the answer would be minus 1. Now it's clear.
Yes, ma'am. And if it is that you have said the 2L plus 1, then how they will ask the
It will
question?
be like it can be in form of 3p, 3d, something like that. So means if it's maybe they can ask directly 3s. So you know na what's L value for s orbital? We discuss SPDF. SL is
0.
0. For p it's 1. Correct. Suppose they will ask 3p. What's 3? 3 means n in that way. Like suppose 3p. What's 3? 3 corresponds to the nth value, no? And what's p? Like for p you know the L value. So in terms of that you can calculate the p and d. Because what's p? You know p and q is L plus 1, 2L plus 1 and n plus L. So now you know what's the value of L. So you can easily put the L value and calculate the p and q. For q you need n and L both values. So in that way.
Okay, ma'am. And ma'am, in what way they can ask the short questions like,
Like I don't
uh,
know actually. I'm not settling things paper.
Ma'am, in week one, there was a question like, I'm still not able to understand that an electron and photon have same kinetic energy, which has greater wavelength.
That I have already, I guess maybe I don't know. You have posted, someone has posted
Uh,
that the same question that I
so,
responded to it also.
and
Because it
so
was
if
asked, yeah.
if the same question comes up in exam, what should we answer? Like
Like I have
photon or
already, like I have told you now that in the forum also I have answered to that. That will the answer only.
photon itself? Okay.
Yeah. Okay, so that, thank you. That's all. for the session.
Ma'am, any notes, ma'am,
Any
for
notes?
for revision, ma'am, if you have.
No, I haven't made any notes. Like it's just the
Because
presentation.
it,
Maybe presentation slides are like I think given to you as well. No? It's also shared with you.
yes, ma'am.
So
Other thing is,
no, I don't have any notes. I think lecture notes will be given to you in the portal itself. So you can take that notes.
that's what not uploaded, ma'am. That's why we are asking you.
Okay. Maybe you can directly email the instructor directly, like instead of writing the discussion forum, just directly mail the instructor.
Is there any mail ID, ma'am, of instructor in
It
the
will be, I
portal?
think, given in the portal, or like you can search on the net also.
It is given on the
Okay.
portal, but they are not responding.
Maybe he will respond, like just send it the mail. Okay, then that's all for today. Thank you.
Thank you,
Thank you,
ma'am.
Thank
ma'am.
you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, much.